This video will give examples with recursive formulas. List the first 5 terms of the sequence. We're given the first 2 terms, and we're given that an plus 1 equals an plus an minus 1 for n is greater than or equal to 2. So let's just start by plugging in n equals 2. Then that means that a of 3 equals a2 plus a1. Since we're given a2 and a1, we can just plug those in. So that means that we have 3. Now let's plug in n equals 3. This gives us a4 equals a3 plus a2. We can use a3 that we just found and the a2 given to us, so we have that this is 5. Then n equals 4. a5 equals a4 plus a3. Using both of the values that we just found, we have 5 plus 3, or 8. So this means that our sequence is 1, 2, 3, 5, 8. And there's a very famous sequence called the Fibonacci sequence. That also works where each term is the sum of the previous 2, except that starts with 2 1s, and so it goes on very much like our sequence here. Write a recursive formula from the explicit formula an equals 2n plus 5. We can begin by just writing out a few terms of this sequence. So a1 equals 2 times 1 plus 5, or 7. a2 equals 2 times 2 plus 5, or 9. a3 equals 2 times 3 plus 5, 11. So now that we've gotten the basic idea, you can see that this is an arithmetic sequence starting at 7 and with a difference of 2. This means that in order to get the next term, we're just going to add 2 to the previous term. Or in other words, an plus 1 equals an plus 2. And now all we have to do is specify the starting term, a1 equals 7. Write a recursive and an explicit formula for the sequence. I'll begin with recursive because that's a bit easier. If we look carefully at each of the terms, we see that it is equal to 2 times the previous term plus 1. So that means that we can write as our recursive formula an plus 1 equals 2 times an plus 1 for n greater than or equal to 1, and a1 equals 1. For the explicit formula, if we look at the elements here, we can see that they're all equal to 1 less than a power of 2. So with a bit more thinking, we can come up with an explicit formula that says an equals 2 to the power of n minus 1. You have a savings account that earns 3% interest monthly. You deposit $100 at the end of each month. Write a recursive formula for the balance. So let's just say that right now we have an dollars in the account. Then what happens at the end of the month? We're going to be earning interest on whatever money we have. So this means that we'll end up with 1.03 times an. And we're also depositing $100. So we're just going to add 100 at the end here. And this is the amount of money that we have at the end of the month, which we can write as an plus 1. Find the third iterate of f of x equals x squared minus 4, xo equals negative 2. So first, we can just plug in f of xo. So that'll give us negative 2 squared minus 4, or 0. Now we're going to take this 0 and plug it in. F of 0 equals 0 squared minus 4, or negative 4. And now we're going to take our negative 4 and plug that in. So f of negative 4 equals negative 4 squared minus 4, which is 16 minus 4, or 12. And now we have that 0 is the first iterate, negative 4 is the second, so 12 is the third iterate.